All right, here we go. So guys, if you could take out a sheet of paper if you want to take down notes. If you're more comfortable just listening, that's okay too. All right. So this is a review of rule number 1. It says 3x squared times 5x to the 4th power. All right, so rule 1, here we go. When we have two things that are being multiplied by each other, and you have the same base, the rule is that what do you do to the exponents? You add them. So 3x squared times 5x to the 4th. Understand that 3 and 5 are not exponents. They're just regular numbers, so they follow just normal multiplication rules. So what's 3 times 5? 15 x to the 6th. That's rule 1. I add the exponents, and I only can add them because they have the same base. If this was like x squared and y to the 4th, I could not add them. Any questions? Let's do another. Let's say we have negative 4xy to the 3rd times 5x squared y to the 10th. So I know that this is rule 1 because the parentheses are back to back. That's multiplication. So understand that negative 4 and 5 are not exponents, so they don't follow the normal exponent rules. They just follow the normal multiplication rules. So what is negative 4 times 5? Negative 20. And then what is the exponent of this x? There's a 1. So what's x to the 1st times x to the 2nd? X to the 3rd. Good? And then what's y to the 3rd times y to the 10th? Y to the 13th. Y to the 13th. Again, when you have the same base, what is the rule? You add the exponents. This is rule 1. Good? Moving on to rule number 2. Rule number 2 looks like this. Rule number 2 says this. When you have something that's being raised to an exponent, here's how these exponents interact. This time it's going to be multiplication. But you have to remember, guys, this 5 right here is not an exponent, so it does not follow the exponent rules. This is just normal exponent, normal 5 to the 3rd power. You understand what I'm saying? So what is 5 to the 3rd power? It's 125. It's not 5 times 3. It's 5 times itself 3 times. 5 times 5 times 5, which, as he said, is 125. And then what is going to be the new exponent of my x? X to the 6th. That is rule number 2. Got it? Yeah. Let's do a little combination here. So let's say I have 4xy to the 3rd squared times xy to the 5th. Okay? What's 4 squared? 16. What's going to be the new exponent of this x right here? 2. X squared. What's going to be the new exponent of this y? Y to the 6th. And then it says times xy to the 5th. So what is the invisible number in front of here? There's just a 1. 16 times 1 is 16. What's x squared times x? X to the 3rd. Because what rule am I doing right now? Rule 1. So this is a combination of using rule 1 and rule 2. So this is x to the 3rd. And then y to the 6th times y to the 5th is y to the 11th. That is rule 2. So that's our quick review over rule 1 and rule 2. Good? Okay, we'll get to it. All right, so rule 3 looks like this. Rule 3 is when you have division between two things. Okay? So let's review. We've done multiplication. We've done like x third times x to the 5th, which is x to the 8th. And then we did x third raised to the 5th power, which is x to the 15th. Now we're doing division. 10 and 15 are not exponents here. That's just a normal 10 divided by 15, which is a normal fraction, and you can simplify that fraction. You could use your calculator, or you can do it in your head. What number goes in both 10 and 15? 5. 5 goes into 10 twice. 5 goes into 15 3 times. So 10 over 15 simplifies to 2/3. Are you with me? Moving on. Now here's how this works. It's x to the third divided by x to the seventh. What we do here is we subtract the exponents when we have division and we have the same base, which is what we have here. So what's 7 minus 3? 4. So the answer to x to the third divided by x to the seventh is x to the fourth. The only question is, where do I put it? Where I always put it where the bigger number was. And where was the bigger number in this case? In the denominator. So x to the fourth goes right here. That is rule number 3. Real simple. Let's move on to the y's. The y's, I have y to the fourth. And what is the exponent of this y? 1. So what's 4 minus 1? 3. So where do I put y to the third? In the numerator. How do I know the numerator? Because that's where y to the fourth, the bigger, was. Y to the third. Now look, can I do 4 minus 3 right here? Why not? They don't have the same base. This is y to the third and x to the fourth. You only can do it if you have the same base. That is rule number 3. Let me go over a quick, another one here. Let's say we have 3x to the fourth, y squared over 6, x to the sixth, y to the 10th. Actually, not y to the 10th. That's fine. And let's just do squared. Now, there's a lot for me to do inside here before I even do anything with this exponent of 2. You see me? Our 3 and 6 exponents, what does 3 over 6 simplify to? 1/2. Yeah? So here we go. So this is, yeah, but I can, order of operations, I'm going to do everything on the inside first, and then I'm going to apply the exponent of 2. So 1/2. What is x to the fourth over x? Actually, I'm going to change this, guys, just to make. What is x to the 14th over x to the 6th? X to the 8th, and where does it go? It goes in the numerator. So I have x to the 8th right here. Very good. What rule did we just use? Rule 3. What's y squared over y to the 10th? What's 10 minus 2? It's 8, so it's y to the 8th, but where do I put it? In the denominator. All of this is raised to what exponent? To the second. Now I'm ready. Now I'm about to do rule 2. So guys, what's 1 squared? What's 1 times 1? Just 1, so that's not going to change. Actually, I don't need to write it because I only would really write the 1 if there was nothing else there, but there's going to be this guy there. So what's x to the 8th raised to the second power? How do the 8 and the 2 interact? What do they do? What do the 8 and the 2 do? Multiply. So this is x to the 16th. What's 2 to the second power? 4. Y to the 8th raised to the second power is y to the 16th. Can you do anything further? Can you do 16 minus 16? Why not? They don't have the same base. This is x to the 16th, and this is y. You're done right there. That's rule number 3. Any questions? We're moving too quickly? Sit down. Huh? Be specific. That's not specific. All right, we will circle back. I promise. We'll do lots and lots. All right, here we go. This is rule 4. So So guys, just looking at this one, how is this one different than the other ones we've been doing today? What is different about it? What do we have? Negative. Be specific. Negative what? Exponents. We have negative exponents this time. So that's what rule 4 deals with. So here we go. 5 and 8 are not exponents. 5 and 8 cannot be simplified, so I'm just going to do 5 over 8. Okay? Now, this says x to the negative 3, x to the negative third, right? So what you do is, when you have a number, when you have a negative exponent, here's a key word, you move it. Meaning, this x to the negative third right now is where? It's in the numerator. So I'm going to move x to the negative third to the denominator, and when it gets there, it turns positive. This x to the negative third is going to move here, and it turns positive when that happens. That's rule 4. I haven't done that yet. I'm just telling you that's what's happening with this. Here you have another exponent that is negative. So guess where x to the negative 10th is going to move? To the top. And when it does that, it turns positive. Look. Then moving on, I have y to the 5th. Does y to the 5th move? Why not? Because it's not negative. So that stays put. Okay. Now understand the operation between here is multiplication. And then you have y to the negative 2nd in the denominator. So where is that going to move? To the numerator. So and then it turns positive. So that's times y squared. So now when you're looking at this, you can recognize that there's more to do. Can you simplify 5 over 8? You can't. So you just write that. But look, so you have x to the 10th over x to the 3rd. What rule are we going to use here? Rule 3, the division rule, right? When you have division and you have the same base, what do you do to the exponents? You subtract them. So what's 10 minus 3? 7. So it's x to the 7th, but where do I put x to the 7th? This is what? In the top, because 10 is bigger than 3. Got that? So x to the 7th goes right here. And then you have y to the 5th times y to the 2nd. What's that going to give you? Y to the 7th. And what rule did we just use to get y to the 7th there? That's rule 1. That's rule 1. So y, and where does y to the 7th go, guys? Now notice, I do not have to put multiplication symbols between here. When you write a variable next to a variable, if you don't have any operation, the assumed operation is multiplication. So it looks cleaner, we'll use that word, to not have the x to the 7th dot y to the 7th. You understand me? Okay, I'm going to do one more problem and then we'll be done with the recording. Here we go. This is about as complicated as it's going to get. We're going to use probably all 4 rules in this problem. Now, all of this is being raised to what exponent? I'm going to try to simplify everything on the inside of the parentheses before I do this. Are you with me? Here we go. 15 over 20 can be simplified to what? 3 over 4. 3 over 4. Can you do anything with x to the 4th right now? Come on, guys.
No.
Why not? It's positive, right? So I'm just going to keep x to the 4th. It's going to stay right there. But then in the denominator, you have x to the negative 6. So what's going to happen to x to the negative 6th? It's going to move up, right? So now you have x to the 6th right here. Very good. So guys, look at this. Before we move on, what are you going to do between x to the 4th and x to the 6th? Technically, it's multiplication, but right, the rule says that if you're multiplying things that have the same base, you add the exponent. So that's going to eventually turn into x to the 10th. Moving on. Both of my y's have negative exponents, so what's going to happen to them? They're essentially just going to switch places, right? So in the denominator, I'm going to have y to the, talk to me, 5th. In the numerator, I'm going to have y to the 12th. Here we go. You can't simplify. This is still raised to the 2nd power. Let's make sure we don't forget that. I still have 3 over 4. Guys, what's x to the 4th times x to the 6th? What rule is that? First rule. That's the first rule. When you're multiplying, that's rule number 1. Power to power is rule number 2. Division is rule number 3. Negative exponents is rule number 4. Got it? So x to the 4th times x to the 6th is x to the 10th. Yeah? And then I have y to the 12th over y to the 5th. So what's going to be the new exponent of my y? Y to the 7th. And where is it going to go? In the numerator or the denominator? Up top. Up top. 12. So this is y to the 7th. Now, remember, all of this is still being raised to the power of 2. Now, is there anything more that I can do inside the parentheses?
No.
There's not. So now I'm ready to apply the exponent of 2. Ready?
Yes.
Guys, what's 3 squared? 9. How did this 10 and this 2 interact? Multiply. What rule are we using right here?
Rule 2.
Rule 2. So what is going to be the new exponent of my x? 20. Y to the 14th over Let me give you a little hint. If you simplify first, whenever you square this or cube this or whatever it's going to be, these numbers will never be able to be simplified. 9 over 16, there's no number that they have in common. That's rule number 4. Any questions?
No.
You guys are taking a quiz on this next class. We're going to practice for the next hour. We're just going to get better and better and better. Okay? We're going to do some individual work, maybe do some group work, and then we will do whiteboards at the end.
Some milk.